Hello, good evening. This is Rio, and this is my presentation of my physics project. Use a meter stick to measure the reaction time of a person. So let's continue. Yes, the first thing is how did I make the meter stick and the shield? So I went to the Home Depot in Seattle and bought some paint sticks and a big cardboard as Mr. Wellman told us. And then I went home and cut the cardboard into two parts with equal lengths. The first part I used it to build a shield, so I just folded it like a triangle and used some glue to glue it and use some tape to like fix it fixed. And then at two sides I cut like 5 cm off and then 10 cm off, so it makes a difference at the length. So the shortest length of the shield is 1 meter, and the second shortest one is like 105 meter, and the longest one is like 110 meters. I mean centimeters. I'm sorry. And then about the meter stick, I just use 2 layers of cardboards to make it, and I use like the paint stick between the 2 layers so they will get stiffer. And then I figure out what should be printed at the on the meter stick. I figure it out. It's the data I put here. This is the length from let's see 0.5 millimeters to 1000 millimeters, and this is the first column of reaction time. This is for the shield with let me see no extensions. This is for the shield with a 5 centimeter extension, and this is for the shield with 10 centimeter extension. Okay, and yeah, this is the distance and fallen versus time in seconds. And the first column is the millisecond. So every row is like 10 millisecond increment, and this is the corresponding distance fallen. And at the other hand, this is a little different. This is a distance fallen with versus reaction time in milliseconds. So in this table, I have 5 millimeters increment in each row, and this is the corresponding reaction time. Yeah, and this is the table that I use. Okay, so back to the PowerPoint. What equations did I use to get my results? First, I need to find the initial velocity when the bottom of the meter sticks passes the bottom of the shield. So I use the third equation of kinematic equation, Vt squared equals V's initial square plus 2 times acceleration and the delta x. In this case, the v0 is 0, so we can ignore it, and the acceleration is just the gravitational acceleration, so it's 9.8 meter per second per second. So we get the initial velocity for the free fall, and then we can plug that into the second equation of the kinematic motion. S equals S initial plus V initial times t plus 1/2 times the acceleration and the time square. And in this case, v0 is the thing we got here, and then a is also 9.8 meter per second, and the s is just the distance fallen here. So we plug those in. We solve for t by using the quadratic formula, and we got the reaction time. Okay, so measurements I took. I asked 3 persons to participate in my experience, and they are all right-handed. The first guy is my family, is one of my family members, and she is right-handed, and I took these are the data that I collected from her, and this is a little small, I'm sorry about that. I also recorded it in here in my Excel file, so it's more complete, and you can zoom in or zoom out if you want to. So I took 5 milliseconds, 2 milliseconds, and 2 milliseconds for the estimated errors for each d value. This is for the 0 d. This is for the 5 centimeter d, and this is for the 10 centimeter d. Because when we don't have any d value, it's better to have a bigger estimated error. And this is the second one, and the third one. Okay, so does accuracy depend on, I'm sorry for this typo, on reaction time? I don't think so. If the subject does not make big mistakes, like this time the reaction time is like 0.8 seconds and the next time is 1.8 seconds, the accuracy will not be affected like very much, because according to my measurements, the accuracies tend to be similar. You can see it here, 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 and here. They are pretty similar. So I don't think it depends on the reaction time. And the second question is, does the accuracy depend on sorry about the typo again, on the d value? Yes, I do think so, because well, I think there are 2 evidences. One is from here. It says it could be improved by using a bigger d, because when you use bigger d, the initial velocity will be like faster, and the numbers of your reaction time at the early stage will be like more separate. It will not be just like 1, 2, 3. It will more likely to be like 1, 4, 7 or something. So you get like more accurate answers. And pros and cons are for having d equals 25 centimeters, which is 250 millimeters. The pro side is that the data will be more accurate, as the numbers will be more separate, as we discussed here. But the cons is that it's not that easy to find such a long cardboard. Mine is like the biggest one that I found in Home Depot, and it's just like 111 centimeters long, so it's pretty lucky. And I don't think I can find a cardboard that is that long in Home Depot. And also it takes more measurements, which will slow down the whole experience, and the subject may not be happy. Yeah, these are the pros and cons. Okay, thank you very much for your time, for watching. I'm Rio, and have a good day. Thank you.